Okay, so starting off with the Unit 2C test review, one thing I do want to note is that on number 1 and 2, if you're watching this really early, we might not have covered 2, and definitely if you're watching on the weekend, we haven't covered number 1 yet. Number 1 will be covered on Monday and Tuesday of test week. So, but number 1, it wants us to plot the following points on the coordinate plane above, and you'll see this is a weird looking one, and it's called a semi-log plot. So plot, and this is found in topic 2.15, like the notes for that. And really all this is doing is creating a graph that makes logarithmic functions look linear. So the y-axis is logarithmically scaled, so that's why it goes together like this. So 2, 3, 4, 5, 6, 7, 8, 9. So as I slowly go up, the gaps become closer and closer because it's scaled for a logarithm. And what this would look like is for A, 0, 5, that would be right here in blue, A. And then for B, 1, 300, the way this works, same thing here. So I start at 200, then I skip by that amount. So I start at 100, then 200, 300. So 1, 300 would be right here. That is B. And then C, 220. So once again, after the 10, I'm counting by 10s. 10, 20, so 220. D is 150. So 150 would be halfway between 100 and 200 right here. That is D. And then E would be for 100, so right here. So once again, the biggest difference between how this is scaled and how other ones are scaled is you are going up by what this amount is. So ones, I'm going up by ones. Tens, I'm going up by 10, so 20, 30, 40, 50, 60, 70. Hundreds, I go up by 100. If I went above 1,000, I'll go up by thousands. That's a logarithmically scaled semi-log plot. So then, as you can see here on number 2, this is the only question you can use a calculator on the test. I'll have a system of how to do this, but for all intents and purposes on this problem, it says use a regression function on your calculator to find a logarithmic function in the form a plus b ln of x, and then use that function to find value for f of 7. So let's go ahead. Let me pull up this review on my computer really quick. Just so I can be in my calculator and do it at the same time. One second. Should have this pulled up already. There we go. So I'm going to go into my calculator here. And remember, you go to second stat to type into the list. And let me go ahead and clear my calculator. So second. Oh, so no, not second stat. Stat edit. There we go. Edit L1. So I want to go to stat, not second stat. Edit. And then just type in my charts. On the left side, I'm going to type in the x's. So 2, 3, 6, 8. Move over. 7, 13, 24, and 27. Okay. So then after I type this in, I go back into stat and go to calc, and then I want a ln regression. So like ln is log base e. I'm doing a log base e regression basically. And then, boom. So the r squared and r I do not need. I just need a plus b ln x. So a is going to be negative 3.13. So the equation would be y equals negative 3.13 plus 14.7, we'll say. Or we'll do it to the nearest hundred. So plus 14.75. Okay, so that's my equation. Now what I would do is come in here and I want to find f of 7. So I would say f of 7, and really this could be rewritten as f of x instead. So f of 7 equals negative 3.13 plus 1475 ln of 7. Okay, and I just typed that straight into my calculator. So I'm just evaluating that function that I found for 7. So negative 3.13 plus, oh, wrong one, plus 14.75 ln, which is right beside 4. So right between 7 and 4 on the left, ln of 7, which is approximately 25.57. And I know it doesn't say what to round to here. 25.57. It doesn't say exactly what to round to here, but this would be a multiple choice question, so you would just round to whatever the multiple choice would have you do. So then we go to number 3. Solve each of the following for x. Be sure to check for extraneous solutions when necessary. So remember, this extraneous part is only when I have logs slash ln, like logs or ln in original equation. Okay. Yep. What's up?
Can I ask you some questions for this presentation?
Let me finish recording this real quick. Like you can sit here for a second. So on 3A, for example, we'll do A and then we'll stop there and then pick up in another video. So on this one, I do have ln, so I'm going to have to check for extraneous. Okay, and you do that by plug in solutions. Plug in solutions to each argument that has x in it. So you just plug it in the solutions, plug it in your solutions to each argument that has an x in it. So for example, right here, I'm going to solve this. So first thing I would do is minus 13, and remember the rest of this section is without a calculator. So when I look at this, I have 5 ln 4x minus 7 equals 20. Divide by 5 on both sides. That gives me ln of 4x minus 7 equals 4. Okay, and then right here, I'm going to do e as the base on both sides. So that gives me 4x minus 7 equals e to the 4th. Add 7. Then I would divide by 4 on both sides to get x equals e to the 4th plus 7 over 4. And now if I was to plug this back in, right here, if I was to plug this back in to make sure that it works, because remember, I can't have a negative in my argument. So I would plug it in 4 times e to the 4th plus 7 over 4 minus 7. So the 4th would cancel out. I'd have e to the 4th plus 7 minus 7. And I'd be left with just e to the 4th, which is positive. Therefore, this is the solution.